Hello there, guys. My name is Karthik, and today I'm going to explain you a medium level problem on Leetcode, which is the longest substring without repeating characters. So, given a string ABC, ABCBB, we need to find a substring which is unique in characters. For example, ABC, that's unique in character. Okay, I'll explain it on board. So if I take this string, suppose string s, uh, equals what was given a b a b c a b c b b. So string a b c a b c b b. So this is a substring of unique character. This is a substring of unique character, but this is not a substring of unique character because B and B repeats in the substring. Similarly, this is not a unique character because A and A repeats in the substring. So duplication exists in the substring. Uh, if you look at this side, BCA, that's a unique substring. So a substring with unique characters. So we have to develop a program where the substring that we generate must be unique. So there are two approaches for this. One is the brute force approach. The brute force approach, which is, suppose I take the character A B C A B C B B. When it's allocated in memory, it has the following indexes 0, 1, 2. I think I should redraw this. 0, 1, 2, 3, 4, 5, 6, 7. This is B. So the brute force approach would be, I would take two pointers, I and J, and I would fixate I and move J along the path and form all the substring. So, if I fixate on 0, the substring would be A, B, C, A, B, A, here will be A, B, A. When I move here, it's gonna be A, B, sorry, it's A, B, C, A, B, C, A, B, right? If I move here, it's gonna be A, B, C, A, B, C, and when I move here, it's gonna be A, B, C, A, B, C, B, and finally, when I move here, it's gonna be A, B, C, A, B, C, B, B. So out of this, what are the unique substrings? This is unique. This is not unique. Only one is unique here, this and this. So the size of this is 1, size of this is 2. So rest of all has unique characters. So the max value is 2. So I'm not sure if I forgot to explain But once we find the length of the unique character, we need to find the maximum value, the maximum length of the string. Uh, yeah, so yeah, so we can identify that there are only two. Similarly, uh, we can increment I to here, fixate I here, and j similarly we can iterate from here to here, and generate everything, and calculate all the individual frames. Sorry, all the individual substrings that it can form and its respective size, and, with the unique elements, and calculate the maximum uh, window frame that it might have, or the substring size. So if you look at it, fixating one and iterating through n elements, that's like for every one operation. So if the string is size n, okay, if string is size n, for every one element that I fixate, it iterates n times. So for nth element also it iterates n times. So the total number of iteration maximum it can form is n cross n. So the time complexity is O of n cross n, which is O of n square. So from my perspective, we can reduce this and generate some kind of sliding window. So how can I do this? Oh. So suppose the string is s equals abc, abc, bb, 1 0 1 2 3 4 5 6 7. So I will initially keep I here and j here. Okay, so I equals 0, j equals 0, and we will calculate the cost. So cost, or the length, right? Length is more makes sense, which is j minus I plus 1, which is 0 minus 0 plus 1, which is 1, right? So now what you're going to do is you're going to keep track of every element and its subsequent index. So suppose MP is the is a map which maps every character to its index. So suppose this is, so first we will keep j at a point and check whether j exists in the map or not. So it seems like j is not there in the map since the map is empty initially. So I'm gonna put j here and its subsequent, sorry about that, not j, the value, which is a, right? So a and the subsequent value is index is 0. Subsequent values 0. Okay, I think I should make 0 a bit better. Subsequent values 0. Now I'm going to increment j. So I will keep track. So b, is it there in the map? No. Like b, and I'm gonna keep the index of b as 1. So now so now I'm gonna estimate the cost for this, which is the length. So that would be 0 minus 1 plus 1, right? 0 minus, sorry, 1 minus 0 plus 1, which is 1. Sorry, 2. So we got cost equal to for this. Now we're gonna go to the next index, which is C. Now I'll check whether C exists in the map or not. So C is not, so I'm gonna take C and store this subsequent index. Okay. Yeah. And then I want to estimate the cost, right? So ABC. So that's 0 minus 2 plus 1. 2 minus 0 plus 1, that is 3. Right? It's 3. Now I'm gonna increment J again. So now it's A. Now I see that A is already present in the array. So now I'll check whether A is present, sorry, in the map or not. So I check that A is in the 0th index. That means A is repeating at this index. So what I'm gonna do is I'm gonna update my value of I in such a way that I'm gonna push it to the immediate next of the index, and I'm gonna update this index by its new value, which is 3, and I'm gonna estimate the cost. So I is 1 and j is 3. So 3 minus, sorry, 1, 3 minus 1 plus 1, that is 3. So the immediate value is 3. Okay. If I'll just write it. So it's 1 minus, sorry, 3 minus 1 plus 1, which is 3. Now I'm going to increment j. Now I notice that when I increment j, which is at the 4th index, I have noticed that b is the character in the 4th string, and it exists in the map at position 1, the index 1. So what I'm going to do is I'm going to increment, I'm going to locate the value of b, which is here, and I'm going to update in such a way that it's going to be the index value of that found element plus 1. So it's 1 plus 1 is 2. And now I'm going to update the b value by 4. Okay. Now I'm going to find the cost. So it is 2 minus 4, 4 minus 2 plus 1. So the length, new length, another length is 4 minus 2 plus 1, which is 3. Again, now I'm going to update it here. Same situation. 2. So I'm going to stay. I'm going to go here. This is going to be 5 now. It's going to be 5 now. Sorry. It's going to be 5 now. Okay. And cost the cost. I'm going to just yeah, did I miss anything? Yeah, okay. So this value is 3 minus 2 plus 1, that's 3. I want to increment this again. J. Now I'm gonna, so it's at, it found B. at the 6th position. I want to check whether B exists in the map or not. It exists at position 4. So it's gonna be the index after that. So it would be the 5th, right? B plus 1. Position map of index of B plus 1. So that is 4 plus 1. So I is gonna come here. Now I'm gonna calculate the distance. So it's 6 minus 5 plus 1. That is 2. So it's 2. And then I'm gonna of course I'm gonna update sorry addition to update this as the decent one. Now I'm gonna go here. So I is so it's B. So we're gonna check. I mean we got B again, so we're gonna check B in the map. It's in the 6th position. So I'm gonna take I to the Bth index, the index of B plus 1. It's gonna be 7. So this is 7 minus 7 plus 1, that is 1. So this are the lengths that I found with unique elements of an array. So out of this, the maximum one is 3, right? So the length is 3, right? So additionally, I could try another example, perhaps. Um, try a good example, I guess. I can try. Oh, this not needed. Let me just try x, 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 a, b, c, d. I'll go with b, d, a, c, b, perhaps 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I here, J here. So I'm going to create the map. So initialize here. It's going to check whether the element is present in the map or not. So x. So 0. Now I'm going to go here. So length is equal to 1. You go here. It's the same. So I'm going to increment. So I'm going to change the ith value to here because it's 0th index plus 1. And I'm going to update this and find the length. It's 1 again. Then I'm going to increment j, the jth pointer, to here. I realize that it's the same. So I locate where the index is. This is I plus 1. So which is 2 minus 1. So it's 2 minus 2 plus 1. It's also 1 again. I'm going to j index here. A is not located, so I'm going to keep A at position 3. Then I'm going to calculate the cost. 2 minus 3 minus 2 plus 1. It is 2. Now I'm going to increment the pointer again to B. So B is there. It's not found in the map, so B equals 4. Find the cost. 2 minus 2, 4 minus 2 plus 1, that is 3. Increment J. Now it's 5th index C, the 5th index. So it's 5 minus 2 plus 1, it's 4. Now D. when I increase. So D is in the sixth index. So that's 6 minus 2 plus 1, that is 5. Right. Go to the next index. So now it's D. Now locate whether D is there in the index or not. It's there, it's here. So what I'm gonna do is I'm gonna place the I in the seventh index because D is here. So I want the array after this, right? I want this part, right? I want this part, right? I want this part now. So it's gonna be here. Now I'm gonna increment J. Oh, sorry, I forgot to take the difference. So 7 minus 8 plus 1 is 2. And D is gonna be, update D to 8. So yeah, now I'm gonna increment J to here. BDA, that's 3. Another thing is, now thing is that A is there. Just gonna check whether A is in the array or not, list or not, sorry, the map or not. If you think about it, A is 3, but but if I take the next index after 3, it's gonna be 4. So that's not, so if I place the I here, that means I went back and I might not get what I want because I has reached till here, so there's no point of it going to the back because it's just gonna mess up the result. Sorry about that. So, so where was I? Eighth index. So yeah, so there's no point of I going back because I has reached till here. So we only need to consider the substrings after after the ith location. So if the index which is located is lesser than I, then there's no point of considering it. There's no point of updating I. So what we have to do is we just change the value of A with the one found and just find the cost directly. So it's 7 minus 3, 7 minus 9, which is 3. Sorry, 7 minus 9, which is 2, plus 1 is 3. So now increment J, nothing's there, so it's 4. Now increment J, it's B. I check if B is in the map and whether it's lesser than or equal to, sorry, greater than or equal to the index size. So sorry, B is 4. So I think I need to update B. I forgot to update B. So yeah, so update B and find the difference. I minus J, which is 11. 11 minus 7 is, I guess, 4. 4 plus 1 is 5. So it's 5. So what is the max of this? It's 5. So the length is equal to 5. So so how would this look like? This is a two-pointer approach. So this will go till I, and the jth point also will go linearly. So since it's two pointers, I guess time complexity would be O of 2n. One for the pointer moving this side, one for the pointer going, one for the ith pointer, one for the jth pointer movement. But this is O of n itself because it's a linear function, right? Because this is n and this is 2n. So I mean it's a linear function. So however linear it is, we don't care about these extra constants. So it's a linear time complexity, so it's O of n. So yeah. So how does a pseudocode look like, right? So so we need two functions, right? One is I, right? Which is allocated 0. One is j, which is allocated 0. Then LFN, which is the array size. Then I guess we need a loop. So j less than n, right? And oh yeah, we need a map too, right? I'll just keep the map here. I'll just erase everything and just write the code in C++. Okay, nice. Let's take another color. So yeah, nice. So we need I initialize to 0 and j initialize to 0. And we need a map, right? We need a n size, which is the arrays or the vector, whatever you use, the length of that, right? So and note this is a pseudocode. It's not an actual code. So I just wrote this to make a basic understanding. So while j less than n, which is the loop, first I will see whether the element is present or not. So if a of j present in, I think it's better to put in instead, as so if a of j is in map and and map of a of j is greater than or equal to the I value, then I can update I as the map value of a of j is 1, right? Otherwise I'll just update and then I'll just update the map value just outside the if statement with the value of I j if it's not present. And I'm gonna take the length, right? I'll just put cost or length, right? You can put anything you want. So cost is equal to maximum of cost with the length size j minus I plus 1. And then and then I can just update the value of j, right? So once the block is over, right? Once the block is over, I just return the value of cost. Okay, I just want to say this. Not avoid confusion. This is one block, right? This is this while loop is one block. This is the loop, right? This is the return, and this is the declaration. So now let's program this. So I'll be using C++. So let's start. So first I will initialize I value, then I will initialize the j value, then I will initialize the n value, which is the size of the string by unpause. Okay, and then I'm gonna create a while loop with j less than n. So if well, sorry, I have to initialize a map as well. So just just initialize the map with a character and an integer, right? Where character is the size of the array, sorry, the character of the string and its subsequent index. So let it be empty. So I if I find an element in the map of the string, okay, then that means next thing I should check is if the map value of the string is greater than equal to I, then I would change the I value as the map of the uh, of the index of that particular string that was seen initially plus 1. Then I would just update the, the map value to the recent value j such j, and I would increment j. Additionally, I need a cost variable, and I would check if and I would store the maximum cost or the length. So that would be cost comma j minus I plus 1, and I just return the cost. Okay, it has been accepted. Now I'll submit. Okay, it has been accepted. So yeah, that's the solution. Thank you.